We are now looking at some special products for polynomials. Let's first multiply something out that is not really all that special. 5x plus 2 times x plus 7. We have seen this in the last section, how we can multiply this out by first multiplying everything with 5x and then with 2. Now, here's the thing. I can organize my work by doing it in the following way. I first multiply the 2 first, then the outer, then the inner, and then the last 2 ones. And that will be then your famous first, outer, inner, last is what you have first seen this being introduced to you as foiling. Foil something out. So what is the first product? The product of the first terms is 5x times x plus the product of the outer terms would be 5x times 7 plus the product of the inner terms is 2 times x plus the product of the last terms, which would be 2 times 7. And this I will now multiply out. 5x times x, that will give us 5x squared. 5x times 7, that's a positive 35x. 2 times x plus 14. And as always, I'm going to look for like terms when I deal with polynomials. And I do have the outer and the inner product. The outer and the inner product can be combined in a lot of cases. So we have 5x squared, 35 plus 2, that will give us 37x plus 14. So if I am using this foiling method for something more general, then I will end up with 3 very special formulas. We call the first one the binomial sum squared, the binomial difference squared, and the product of the sum and difference of binomials. Now, I do not need to write this down next to each other anymore. Let's just do the first one. Let me explain to you how the first formula comes about. So if I have a plus b squared, then a lot of times I still see this, a plus b times a plus b, which is correct. But we are developing a formula, and I do not need to write it down that way then afterwards anymore. If I FOIL this out, if I use my foiling method, the product of the first, the product of the outer, the product of the inner, and the product of the last, then what I will get is this. The product of the first is a times a, which is a squared, plus the product of the outer is a times b. The product of the inner is b times a, but multiplication can be reversed, is commutative. That means it is the same thing as a times b. And the product of the last is b squared. And now what I have right here on the inside are 2 of the same terms. That means I can combine them. And that will give us, now I have 1 apple, I add another apple. How many apples do I have? I have 2 of those. I have 2 a times b's plus b squared. And this is the formula that we are using. How can you remember that? It is the first one squared, the product of the terms multiplied by 2, plus the last one squared. So this is our binomial sum formula. And that means the product of the terms times 2 plus the last one squared. I can do something similar with subtraction, and it looks almost identical, but there is a negative instead of a positive in the middle. Now, the product and sum of sum and differences is going to be a little bit more surprising. The terms, the product of the outer and the inner is going to cancel out, and we will just have a squared minus b squared. Let's erase this right here so that it looks cleaner. So I have three separate formulas, and these are special compared to the last one because those products are always related to each other. In the first one, it's the same multiplied with each other. In the second one, in the same way, just with the negative in here. And here, this is also somewhat special because the only thing that is different is that one has a minus and the other one has a plus. Not like the last example here, as a quick reminder, these two right here had really nothing special in common. All right, let's do one row of examples that demonstrates all three of these formulas. So 2x plus 3 squared. It goes much faster if I just use my formula that says, what is the first term? That is 2x. The second term is plus 3. So according to my formula, I have my first term squared. I have plus 2 times the product of the terms. And the first term was 2x, and the second term was a positive 3. Plus the last one squared. This last one will always be positive. And if I multiply this out, I'm going to get 2x squared is 2x times 2x. That will be 4x squared. Plus, let's see, 2 times 2x is 4x times 3 is 12x. Or in other words, other way around, 2x times 3 is 6x. Multiplied by 2 will give us 12x plus 9. All right, let's do the same thing with this one. I will get 2x squared minus 2 times the product of the terms. And that will be 2x and 3. Plus the last one squared again. The terms now that I'm multiplying is 2x and 3. So I will end up with 4x squared minus 12x plus 9. Notice that the only difference between these two things is that one has a negative in the end, in the middle, and this one there is a positive in the middle. All right, let's do the last one. This is 2x plus 3 times 2x minus 3. So this is very special. 2x and 3, 2x and 3 in both cases. One has a negative, the other one has a positive. If I would have written it in this way, it would have been the same problem. Multiplication is commutative, it can be reversed. 2 times 3 is the same thing as 3 times 2. So that means now that I'm going to get 2x squared minus 3 squared. And if I multiply this out using the properties from last section, 2x squared again is 4x squared minus 9. We call this also the difference of two squares. Let's have a quick look what happened if I have more than just one variable. So polynomials in several variables. First, like terms. How do like terms look at this moment? Well, they have the same variables with the exact same exponents. So, for example, 2x squared y cubed and 5 x squared, if I would try to add these ones, y cubed. These are like terms, and I can add them by doing the same thing as before. This is a 2. This is a 2. Both x's have an exponent of 2. They have the same exponent. The y's also have the same exponent. Here it is a 3, and here it is also a 3. So the exponents now do not change. I am just adding the coefficients as before. Think about apples. You are comparing apples. 2 plus 5. How many of them do you have? 7 of them. How do we deal with multiplication? Well, multiplication, we are going to multiply the coefficients and add the exponents on variables with the same basis. So this is going to look very similar to what we have done before. What this is all the way multiplication. So I can write this in the following way. This is 4 times 7, x to the third times x, y to the second times y to the fifth, and that will give me 4 times 7, that is 28, x to the third times x to the fourth, to the first, that will be, I'm adding the exponents in this case, y raised to the seventh. So when I'm adding polynomials, I do not change the exponents, but when I multiply, then the exponents with variables of the same base, you will add the exponents.